Hi, everybody. This is a review of the stats 1332 class final exam review. So just to make sure everybody understands, this is math 1342, sorry. 1342 final exam review. All right, let's get this show going. Use the given number. Question number one, use the given frequency distribution to find the class boundaries. So I'm going to put the class boundaries here. These are the class limits, or if it just says classes, then they're the limits. Remember, you can always do the boundaries is a half more of the lowest digit that we have. So we're talking about the ones. So a half more, 0.5 more. So the upper boundary would be 45, then it put a 0.5 on there. Same way here, 49 and put a 0.5. Next one, 53 and put a 0.5. 57 and put a 0.5, 61.5, 65.5, and 69.5. The lower class boundaries is 0.5 less. So 42 minus 0.5 is 41.5. 46 minus 0.5 is 45.5. And if you look, there's 45.5 up there. For boundaries, your lower limit is going to equal the previous upper limit. So if this is 49.5, then the lower limit for the next one is going to be 49.5. 53.5, this will be 53.5. And keep on going and going and going. So these are the boundaries. Now, to find a class width, you only have to subtract two successive boundaries. Subtract these two, 40, the highest one minus the lowest one, and you get 4. So that's our class width. And you can look at this also, 42, 43, 44, and 45. Are our class, that's our class limit, 42, 43, 44, and 45. So if you look over here, 42, 43, 44, 45, do you see how there's only 4 numbers that fit in there? Same way with here. 54, 55, 56, 57. There's only 4 numbers. That's our width. You can find our width by looking up all the numbers in that class limit, or you can subtract successive class limits. 62 minus 58 equals 4, and that's our class width. So the class width for this is 4. Our class boundaries are these right here. All right, let's move on to question 2. Use the data to find the upper and the lower limits of a frequency distribution. So we need to find the upper and lower limits. And they tell us we're going to have 8 classes. So we need to figure out what the class width is. And the formula for class width is the range divided by the number of classes. Range is the highest piece of data minus the lowest piece of data. The highest piece of data looks like it's right here, 98. The lowest piece of data looks like 51. So when I subtract these two, I get 47. That's our range. Maybe I shouldn't have put width there. I should have put range. Here's our formula for width. So this is our range. and range is 47. The number of classes is 8. So the formula, 47 divided by 8 on my calculator. $47 divided by 8. And in decimal form, I get 5.875. You always take it up to the next higher number, next higher digit. So 5.8 goes up to 6. Even if it was 5.001, if there's anything in the decimal spot, you have to take it up to the next highest number. It's called rounding up, next highest whole number. So here, our width equals 5.87, but we round it to 6. So our width is 6. Okay, so to find now all we're doing is finding our class limits. Class limits. You always start off with the lowest number, which is 51. And then we need 6 numbers in our class: 51, 52, 53, 54, 55, and 56. 1, 2, 3, 4, 5, 6. So this goes from 51 to 56. We have 6 numbers in our class. So the next class would be the next number, 57. And it would go to 62. The next class would be 63, and it'd go to 68. How do you tell, once again, our class width is 6. You can subtract 2 successive numbers. Do you see how we did that there? 57 minus 51 is 6. 63 minus 57, you can subtract these 2, is 6. 68 minus 62 is 6. So 68 is our limit here. Next is 69 to 74. Just add 6 here, add 6, you go to 80, add 6 here, you go to 75. And you can keep on going with your class limits until you run out at the end. The last one should be 93 to 98. So this is the answer here. Find our 8 class limits. You just put them in order and you'll have 8. It should run out with all our data. Every class has to have a width of 6 in it. All right, question 3. Question 3, display this as a stem leaf plot. All right, well, you can see I have data 75, 80s, and 90s. So I have data in the 70s, 80s, and 90s. These are our stems, the higher digit, and then our leaves are our lower ones. So if you look at this dot, that dot represents, if this is 75, that dot represents 74. You see 74. And then there's 2 76s here, it looks like. 76, 76. And then we have 79, 79. So this is the stem, these are the leaves. This number represents 74, 76, 76, and 79. In the 80s, I have 4 right at 80, 80, 80, 80, 80. Then I have an 82, looks like. I have 2 84s, 4 85s, and 289s. So this is what the stem leaf looks like for in the 80s. And then 90s, I have two 90s, a 93, it looks like a 94, 95, 96, and finally the last one, 98. So this is what the stem leaf looks like, corresponding that dot plot over to a stem leaf plot. All right, question 4. State how this is skewed. If it's skewed right, skewed left, or if it's symmetrical. What you could do is kind of look at this and trace these. If you look at this, and if I turn this counterclockwise a half a turn, this is what the graph looks like, right? I just turned it a half a turn. And so now we're looking like this. And if you look at this graph, the left side has little data. The left side data. So we call this left skewed. Since the left side has the least amount of data, it's left skewed. If it's symmetrical, it would look like this, you know, pretty much the same half on both sides. Left skewed, and then right skewed looks like this. You see the little data on the left, that's right skewed. Little data on the left, that's left skewed. All right, that's question 4. The answer was left skewed for question 4. Question 5. All right. Question 5, we're going to build a table. We're going to have L1 and then we're going to have L2. L1, L2 is the percentages. So make sure you put the percentages in L2. So first we have 50%, then we had 15%, 20%, 10%, and 5%. And it says 86 is the test, that's the 50%. 86 were on the test. The first one was tests. If you look, tests were 50% for your test, 15% for the midterm, 10% for the lab, 5% or 10% was the lab, 20% was the final. That's 20% was the final, and 5% was the homework. So we had 86, 96 on the midterm, 82 on the final, 98 and 100. So we're going to put these in L1 and these in L2, and the weighted mean is the average on our calculator. So we're going to do that. So let me get my calculator out, problem 5, and let's take a look at this. All right, so I'm going to turn this on. And we're going to create browse, and we're going to go to, I'm going to get the data. I already have the data all lined up for question 5. And there's my data. If you look at question 5, this is the data you should have: 86, 96, 82, 98, 100 for L1, and then the percentages for L2, 50% is 0.5, 15%, 20%, 10%, and 5%. I'm just going to bring my cursor over here to the right and go to menu, 441, 4, stats test, we did 4, and then we did 1, and then we do 1 again, 411. I think I said 441, 411. even though we have two lists, we always only use one list in this class. And I'm going to hit arrow over and I'm going to go to L1, hit enter. Then we have L2 for the frequency list. Enter. And it should give us our mean. Hit OK. Do you want to proceed? Yes. And if you look at our average is 88.6. That's our weighted mean, 88.6. Okay, so for question 5, after we entered everything in, our weighted mean is 88.6. All right, question 6. Compute the correlation coefficient. In other words, correlation coefficient is R and tells us how straight a line is. So I'm going to do the same thing. I'm going to type this into L1 and this into L2, and I'm going to type in what's needed. But before I do that, I want to go back. I do want to go back. Give me a second. I want to go back to 5 and just share with everybody, once again, what I typed into the calculator. I typed in first the data in a data list. And then I typed in, once I typed in the data, I clicked over on the right-hand side and I dialed 411, and we put our list, you know, we had L1 in the first list, L2 in the frequency list. And then when we hit enter, we got our answer 88.6. So we dialed in menu, menu 441. And I might as well show that again. Might as well show that here. So we have our list here, and I'm just going to put it somewhere over here and just go to menu. Number 4 is statistics. 1 is stat calculate, and 1 is one variable stats. We always only do one list. And here we put L1 in there. Here I arrow over twice to put L2 in there. And then come down to OK. Hit enter and hit enter. It overrode my previous work, and there's the average, 88.6. Okay, so now we can go to question 6. And I already said I'm going to enter the first data into L1. And this data into L2. And we want to find R, the correlation coefficient, and we want to find how strong it is or how weak it is. So let's do that. I'm going to go to my calculator. And I want to go to a new, add a spreadsheet, but I think I want to go to a previously saved one. There we go. I'm going to browse. See, I saved this already, so so I don't have to type it in front of everybody if I can get to it. And we're doing question 6. So here's all my, oh. Maybe we're not doing question 6. That says question 5. Let's see if I can find that. Okay, so I did find my question 6 data. I created a new page. I labeled my list L1 and L2 at the top. And if you look at question 6, this is the data, 1.6, 3.6, 4.9, 1.1, and so on. And then the other 4, 28.2, 8, 28.8, and so on. So I have all my data typed in. Over on the right-hand side, it doesn't matter where, just right on the right-hand side, we want to find the correlation coefficient. Okay, so off on the side, we're going to type in menu for A. 4, and then all the way down to linear regression t-test. 4A. Number of variables, 1 always. We have L1 in the first list, L2 in the second list. And then I scroll down till I get OK, hit enter, and yes, erase anything else, enter. Now, if I scroll all the way down, it's going to tell me what R is, if I can get there, unless I passed it already. Give me a second. So we'll try this one more time. I'm going to arrow over to here. Menu 441. Except it wasn't 441, it was 448. A 44A. Hang on, I gotta remember it. Menu 44A. A linear regression. I have to do the A button down here. The A button down here. There we go. And here we're doing L1. Here we're doing L2. And we're going all the way down, hit OK. OK. And if I go down just a little bit, I think I went down too far before. There's my R, 0.882, 0.882. So when I do my R for this particular problem, I put this data in L1, put this data in L2. I first entered my data into the list. I moved over to the right and hit a blank spot, right? Then I went to menu 441. We put L1 into the list, frequency, we put L2, and then eventually we hit enter, and we got R equals 0.882. Okay, so menu 441. And when you do menu 441, 4 is statistics. And then the next 4 was stat tests. And then I keep on saying 441, it's 44A. I keep on apologizing for that. Linear regular t-test. So it's 44A. There we go. Now, make sure you have that correct. To find R, you have to have your data in a list and then go to 44A. And you should get 0.882, which is a positive linear correlation. I don't know if it's a strong, right? A 0.995, you know, closer to 1 is a strong positive. It's not perfect because it would be a perfect 1 then. Hey, you could say it's a strong positive. It's going up. The data is increasing from lowest to highest. 0.882 isn't the strongest correlation coefficient that you could get. Okay, question 7. Based on the data set, your blood platelet counts have a mean of 280. Your standard deviation is 65. Using the empirical rule, what is the approximate percentage with platelets between 215 and 345? 215 and 345. Well, what's 280? Our average is 280. 280 plus 65. If I add 1 standard deviation, I get 345. So I just added 1 standard deviation and I got 345. Now 60 Now 280 is our average minus the 65, you get 215. That's the other one. That's the 280 minus the 65. So either way, 280 is the middle. It's 1 standard deviation more for 345. It's 1 standard deviation less. So what we have here is the average 280 plus or minus 1 standard deviation. So the question is, what was the question? What is the approximate percentage of women between this range? Well, we know 1 standard deviation for the empirical rule means 68% of the data. So that's our answer. Do you see we're 1 standard deviation on both sides? So our answer is 68% of the data. If we were 2 standard deviations away, 65 plus 65, 2 standard deviations away are 95% of the data using the empirical rule, and then 3 standard deviations are 99.7% of the data. So just remember these 3 rules. Our distance here was only 1 standard deviation away from the mean on both sides. So we're dealing with 68% of the data. Remember this, it looked like this. If we had a mean here, 1 standard deviation on both sides is 68%. If you had 2 standard deviations, it would be 95%. And then if you had 3 standard deviations, you'd have 99.7%. But our data was only 1 standard deviation away. So it's 68% of the data. All right, question 8. Find the sample mean. So in order to find a sample mean, you need frequency, which is always in the L2, and then you need the midpoints. When you have data here that's grouped. So you have to find the midpoints of each by adding these up and dividing by 2. So on question 8, you have to add 478. So you have to add up 478 plus 504 and then divide it by 2. And when I get that, I get 491. So that's the midpoint of the first one. Then I add these two up and divide by 2. Add them and divide by 2. I get 518 and so on. I add those two up, 532 and 558. I get 545 when I divide by 2, 572 and 599. So this is what you put in L1. This is what you put in L2. Then you do the 4, 1, 1 on the side, right? Because we're looking for the mean, sample mean. So let me pull that data from my calculator. So I'm going to actually show you typing this into the calculator this time. All right, so let me type this into calculator. So I'm going to go to a new page. I don't want to save my old stuff. So I'm going to go to a data page and I'm going to type in my data. I'm going to put L1 up here, L1. And then up here, I'm going to put L2. And I'm going to type in my data. You're looking for the midpoints. Remember the midpoints were 491, 518, 545. Let's see what happened there. 572 and 599. And the other side on L2, we wanted the frequency. We have 4, 6, 2, 2, 2. Now we click on anywhere to the right. Doesn't matter. Anywhere to the right. And you go to menu 4, 1, 1. And we always use one list. Here, I'm going to put L1. And in frequency list, even though we only use one list, the frequency list, we're going to put L2. And our average, find a sample mean, I get 494. So that doesn't seem right. Give me a second. Okay, so it wasn't right. I did check my data. One of my pieces of data were wrong. So I updated my data. I'm going to go to the right here. Menu 4, 1, 1. This stays at 1. Here, I'm going to go to L1. L1 is my first list. L2 is my second list. Come down to OK. And if we look, my average is 531.5. My average is 531.5. So for this average, 531.5. Once again, frequency list is L2. Midpoints that we find were L1. Now we put all the midpoints here, add these two up and divide by 2. All right, let's try question 9. Question 9, find the coefficient of variation. Coefficient of variation. Formula looks like this. C bar, I think Normally it's just C bar like this. The formula is standard deviation over the average times 100. So we're going to put this data in L1, Obama's data in L1, and maybe McCain's data in L2. We're going to put all this data in there. And for each one, we need to find the S standard deviation, and we need to find the X bar. So we need to find both of those. S over X bar. So we're going to find both of these. And I'm going to grab my calculator. And here's all my data for Obama. Here's all my data for McCain. I typed them in. I even put their names, Obama and McCain. On the right, I'm going to find the data for just Obama right now. I need to find the average and the S. So I go to menu, 411, 411. Going to be one list. It's coming from Obama's. I want to do Obama's. Everything else stays the same because we're not using the other list. We're just getting the data from the first list right now. My average is 653.8 and my standard deviation is 523.21. So I'm going to write both of these down. And then I want to come back and I want to do McCain's data. So I'm going to come over same spot. I'm moving over to the right just a little bit further. McCain's is going to be the second one over here. And I'm going to put it up right here. If it lets me, I guess not. I'm trying to get. Okay, how about just trying to move it over? Okay, it won't let me. Yeah, there it goes. All right, so I'm going to go to menu 411. Hit enter, and this time I'm putting McCain's data in here. And coming down, I hit OK. And there's McCain's data, 458 average, and the S is 418. The S is 418.42. All right, so I have my information. So let me get back to the review and let's type this in. So once again, CVAR. Was S over X bar times 100. So S for Obama, let me go to Obama's data. S was 523.2 and the X bar was 653.8. And for McCain, I get 418.2 over 458.5. All right, so when I put both of these into my calculator, here I get 90. Don't forget about multiplying it by 100 to get the percentage. Here I get 91.3%. And for Obama, I get exactly 80%. All right. So there's definitely a larger correlation coefficient with McCain, if you look at this. And don't forget, anytime you're looking for S or X bar, you're going to go to menu 411. That's just the standard information that they give us. Menu 4, which is stat calculate. 4 is statistics. Then number 4, or then we're going to number 1, stat calculate. And the other one is 1 var statistics. So 411. Anytime you want mean or standard deviation, those are good to get. 411. All right, question 10. Find the 5-number summary and the interquartile range. So 5-number summary consists of your lowest number, your highest number, Q1, your median, and then Q3. Put all this data in a list, list 1. Let's see if I can do that. Okay, so I have my data from this problem all typed in here. And all you have to do is move over to the right and go to menu 4, statistics, 1, stat calculate, and 1 var stats. Our information is in list 1. You'll notice there's only one list. Hit OK. And our 5-number summary, scroll down, starts right here. Minimum is 40. The low number is 40. Q1 is 50. Median is 80. Q3 is 100. And the maximum, the high number, is 115. So all of that is right there on our screen. So I'm going to type all this in once again. Our lowest piece of data was 60. Or you call it low or the minimum, it doesn't matter. Minimum. Oh, it's not 60, it's 40. Q1 was 50. median, or Q2, also known, is 80. Q3 was 100. And then the maximum number was 115. And this is called our 5-number summary. Now they want to find the interquartile range, also known as the IQR. IQR is Q3 minus Q1. Interquartile range Q3, and this problem is 100. Q1 is 50. 100 minus 50 is 50. So the IQR for this problem, interquartile range, is 50. Okay. Let's go to question 11. The monthly utility bills for the city has a mean of 70. So we have a mean of 70 and standard deviation of 8. Find the z-score. So the formula for z is x minus x bar over s. This is finding z for samples. And it says, find the z-score that corresponds to a utility bill of $71 and explain. So here is a normal curve. Our average is 70. That's a z of 0. We want to find the z-score that, what z is a 71. So we want to find the z-score of 71 right here. We want to find out what the z-score equals. The number that we're talking about is 71. That's x. X bar, the average is 70. Standard deviation is 8. So our z-score is 71 minus 70 is 1 over 8. 1 over 8 in decimal form is 0.125, 0.125. But z-scores are always given in normally in 1 decimal place. Or let's say 2, z-scores are normally given in 2 decimal places. So that's our z-score. Z-score equals 0.125, but if we go 2 decimal places, the z equals 0.13. So $71 is 0.13 standard deviations above the mean. Do you see it's larger than the mean? 71 is larger than 70 above the mean because it's positive. All right. Question 12. Identify any potential outliers. All right, so for number 12, to do outliers, you need to know the 5-number summary. So first thing we're going to do is 5-number summary, which we just did. So we want the, once again, the minimum, Q1, median, Q3, and then the maximum. We have to put all this data into L1 and then do menu menu 411. Remember, so first we're putting all the data in a list, and then we're going to menu 411. So if that's what I plan on doing. So here's my calculator. I put all the data into a list. I call it L1. I'm going to move my line over here to the right somewhere. Go to menu 411, hit enter. We're using list 1 only. Everything else goes straight to OK. And I'm going to write down my 5-number summary here. There's my minimum. I even arrowed minimum, Q1, median, Q3, and the maximum. So when I come back over here, I'm going to write all my information down. Minimum piece of data was 21. Q1 was 660. Median was 1891. Q3 is 4749.5. And then maximum is 17,341. So we want to find any outliers. To find outliers, you have to find the IQR first. IQR. Remember, we said that was Q3 minus Q1. Q3 is 4749.5. Q1 was 660. When I subtract the two, I should get 4. I don't know. Let me check. Let me put up another. Oh, I turned my calculator off. Hang on. I need to add a calculator page. 4749.5 minus 660. And I get 4089.5. That's my IQR. So the lower outlier is the average minus 1.5 the IQR. Minus 1.5 times the IQR. The upper outlier is X bar plus 1.5 times the IQR. So the average, once again, what was our average? I need to go back and look at our average on that page. Let's see, it should have been there. Scroll it up. Our average is at the top, or closer to the top. 3417. So our average for this problem, I didn't write it down, was 3417. So our outlier is 3417 minus 1.5 times the IQR, 4089.5. Okay, let's put that in our calculator. Three, 4, 1, 7 minus 1.5 times 4089.5. So if you do that, you get this negative number, negative 2717. That means, because we don't have any negative numbers here, So that means there's no lower outlier. There is no lower outlier. So we're looking for the upper outliers. Our average, which was 3417, plus 1.5 times the IQR. IQR was 4089.5. All right, so let me do that one. 3417 plus 1.5 times 4089.5. And I get 9551.25. So this is the upper outlier. Is there any number higher than 9551? See, we couldn't find any number lower than our negative number because we'd have no negative numbers. But is there any number larger than 9551? And yes, there are two, I think. 9,500, there's this one that's larger than that. And there's this one. So there are two numbers larger than what we got for our upper limit. So since we have two numbers, these two are our outliers. And you saw there's nothing lower than the negative number we got. But 9,500, out of all our data, there were two numbers that were larger than that. So we called them the outlier. Those two with the check marks are our outliers. All right. Question 13. So anytime I do a problem like question 13, first thing I do is I fill in all the gaps. I'm going to add up all of these right here. 9691, 499. So I put all these in my calculator. And this is what I got. I got 20752. And then I added the this row here, and I got 9013. And when I combine those, when I add those together, I got 29765. Now, when I added these going down, I get 11752. I add these going down, 6015, or yeah, this 6012, and then 12001 when I add these going down. These are the totals going down. These are the totals going across. If I add these this way, I should get 29765. Add these going down, I should get 29765 also. So now we can read the question. Find the probability that an electrical engineer is chosen given that the gender is male. We want a probability that an electrical engineer was chosen given that they're male. So we know they're male. So we need to only focus on the male part right here. That's it. We want to find the probability an electrical engineer is chosen. How many electrical engineers are there that are male? 4997. Given that they're male, there's only 20,752 that are male. So we put that in our calculator. 4997 divided by 20752. And the decimal equivalent is 0.24. So about 24%. Rounded to the nearest thousands, tenths, hundred thousandths, one more decimal place, 0.7. So the nearest thousandth would be this answer here. So it said given male, so we're only concentrating on males. So we're only looking at the males. So the only numbers we're looking at are males because it said given that they're males. So 4997 over the total males, that 20,000. And this is what you got. All right. Question 14. A card is drawn from a deck. Find the probability the card is a face card. Well, there are Jack, Queen, and King are face cards. And there are hearts, diamonds, spades, if I could draw a spade, and clubs. So there's 4 times 3. There are 12 face cards. 12 face cards. And or red. So red cards, there are 26. Half of the 52 cards are red. Now, if you look, we counted face cards here, we counted red here, but there were 6 hearts face cards. I mean, there were 3 heart face cards and 3 diamonds. So there were 6 red cards, 6 red that we counted here, and 6 black. And we counted all the red here, but since we counted those 6 red twice, you have to subtract the double reds that we counted, the double reds. Do you see there were 12 face cards? Jack, Queen, King, Jack, Queen, King of hearts and diamonds. But when we counted them, Jack, Queen, King, we counted them here also, hearts and diamonds. So we counted them twice. So we have to subtract 6 cards. 12 plus 26 is 38 minus 6 is 32. Do you see? You have to add these, but then subtract it because we counted it twice, those cards twice, out of 52 total. And when we divide each of these by 4, we get 8 on top and 13 on the bottom. So write your answer as a fraction in lowest terms. It's 8 over 13. There are 8 out of 13. You see how we did that? The face cards, the red cards, but we counted those red cards twice. We counted 6 of them twice, those 6 red face cards. Okay, question 15. "43 cars are started at a race. How many ways can the cars finish first, second, and third?" Well, because they're finishing first, second, and third, order matters. Order matters a lot. It's really important who comes in first place, second place, and third place. Order matters. So there were 43 cards. Order matters means it's a permutation. And we're choosing 3. So this is the question you have to put into your calculator, 43P3. So you have to put 43P3 permutation, picking 3 from 43. All right, so let's do that on my calculator. Picking 3 from 43. We're going to go to menu. I'm getting the wrong one. Probability, menu 5. And then we said permutation number 2. So let's try this again. Yes, there it is. And there's the larger number first, 43. Then we put the comma in. The comma's at the bottom of our calculator. If you look down here at the bottom, there's a comma. 43, comma, picking 3. If I keep it on the right side of the comma. Hit enter. I definitely typed something in wrong. Oh, I hit C. Let's try this again. Menu 5. And we're doing combination. Wait, we're doing permutation 2. And we're doing 43, comma 3. And when I hit enter, there's my answer. This is how many different ways? 74046. So we already said, does order matter? Yes. And we did 43P3. And we get 74046. 74046. This is how many ways a car can finish first, second, and third. Now down here, State Department, a new section of a highway receives 16 bids, and they're gonna hire 4. Now it doesn't matter who gets hired when, they're just gonna hire 4 to do this job, and they're all gonna get paid the same. It doesn't say one's getting paid more than the other. So how many different combinations of 4 for these 16? So this is a combination. Order's not, is the order important? The answer is no, because it's a combination. Or it doesn't matter who gets picked. Well, it matters who gets picked, but it doesn't matter who's picked first or fourth, because first through fourth, they're all still getting the job. So we're going to do 16C4 on our calculator. Menu 5, 1, C is 3, 5, 3, and then we're doing 16, comma, and we said 4. And there's our answer, 1820. 16, choose 4, 1820. And the question is, does order matter on this one? No. And yes, we said, I can't remember what we said up here, but it should have been yes, order mattered. Up here we did 43P3. Here, 16C. I know there's a 4 in here somewhere there. 4 companies are chosen. And you get 1820 for this one. This one we got 74046. All right. Let's move on. A 1,000 components contain 250 bad parts. That's not good. So that's, if you look at that, 250 out of 1,000, that's 0.25%, you know, that's 0.25 or 25%. That's bad. You have defective. 2 components are drawn. I'm going to draw 1 component here, and I'm going to draw 1 component here. Let A be the event that the first component drawn is defective. So we know we have 250 bad ones out of 1,000. That's defective. We know that. There's 250 bad ones. So you have 250 out of 1,000 chance to pick a bad one in that first one. That's what they wanted. First component is defective. Let B be the event that the second component is defective. Okay, so if the first one was defective, now it doesn't tell you. It says 2 components are drawn at random. I'm going to write down here, it should say something like without replacement. So it's not putting, this first one, it has a bad part. It's sitting there. They're not putting it back in the bag. So now the second one defective, there's only 249 left, but there's only 999 left also because we already have one bad one that's sitting out of the bag. So this is the answer. Put this in your calculator, 250 divided by 1,000 times 249 divided by 999, and you should get the answer. And the answer I get is, on my calculator, I get 0.0623, rounded to the thousandths place. So there's my answer. 0.062. Question 18. Okay, so it just says find the mean, standard deviation, and variance for this. Round it to the tens place. So we're going to put this in L1 and we're going to put this in L2. And then we're going to hit 411 menu. 411 and all our data will be in there. All our data will be in there. So we're going to do that. So let's actually do this on my calculator now. So I'm going to start a new page. And we're going to list the data, number 4. Oop. Did I type in something wrong? Did I hit something wrong? New. Yes. All right, wait. I'm really messing this up. Okay, so I'm going to, let's start new. And there we go. And so we're going to type in our list. And I'm going to put L1. And then in the next list, I'm going to type in L2. And in L1, we just had the X values 0, 1, 2, 3, and 4. And here we had 0, 0.05, 0.69, 0.16, 0.08, and 0.02. We're going to arrow over to the right somewhere. And menu 441, menu 4. I keep on saying 441. It's 411. 411. Hit enter here. You only want one list. We're putting L1 here. We're putting L1 here. And in frequency list, we're putting L2. And then we're just going to hit OK. And there's our average, 1.33. Let me move that cursor over to there. There's our average, 1.33. If you look, sample standard deviation didn't have anything, but population standard deviation had the answer 0.77. If I can get it there. Come on, come down. Why won't it go down? I really need to. Anyway, there we go. Population standard deviation is 0.7753, and one decimal place is just 0.8. And then we have to do something to find the variance. So let's go out of here, go back to our workbook. So we already said we put this information in L1, we put this information in L2. When we did 411 menu 411, our average was 1.33, and it says round to one decimal place. Our standard deviation, one decimal place, was 0.77, which is 0.8 in one decimal place. And then now our variance, we standard deviation, but variance is standard deviation squared. So you had to put 0.7753 and square it. So you have to put that whole number in it like that and square it. So I need to put my calculator page up there and put 0.7753 and raise it to the second power. And I get 0.60. That's our variance. So here are all three of our answers: our average, standard deviation, and our variance. All right, question 20. A student takes a 8-question multiple choice test with 4 choices. If there are 4 choices, then he has a 25% chance of getting it correct, right? He has a 1 in 4 chance of getting it correct. He has a 3 in 4 chance of getting it wrong. Find the probability of guessing exactly 7 out of 8 correct. So this is a binomial distribution, and we want to get exactly 7 correct. There are 18 questions. The number that we're going to get is going to be 7. The probability of getting a correct answer is 0.25. So we're going to use binomial distribution for this on our calculator. So just remember these numbers. Okay, so to our calculator. Let's go to just the calculator page, and we're going to go to menu 5, and then A, menu 5, binomial distribution. There were 18 questions, 0.25, 4 questions. So you get a 25% chance of getting one correct. So the probability of getting it correct is 0.25. And there were 7 exactly that we wanted. And remember, you only use PDF when you have an exact answer. Exactly. Hit enter. And there's what we get, 0.082, and that is the answer. So for this problem, we typed in menu 5, 5, and then A. And I'm going to read these off to a menu. 5 is probability. And then the next 5 is distribution. And the next is A. Binomial PDF. And PDF is only when you have an equal sign, when you exactly 7. You use CDF when it's less than or greater than, but exactly 7. We use PDF, 5A. And probability, when we typed in 5A, n equals 17, the probability equals 0.25. And the X value equals 7, correct. And you should have got 0.082 as our answer. All right, let's try question 20. Student guesses a 20 true or false question. Find the probability that there is at least 3 correct answers. So we have 20 questions. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, all the way to 20 correct questions. At least 3. At least 3, that means 3, 4, all of these numbers are possible, right? At least 3 means 3 is the least. So our lowest number correct could be 3. Our highest number correct could be 20. So between 3 and 20 is correct. And we're not exactly 3, so we're not using PDF. We're using 5B, which is CDF. And we're going to use the lowest number 3 and the highest number 20. So let's remember this on our calculator. 20 questions, n equals 20. Probability that you get a true or false question is 50%. 50% true, 50% false, right? 2 questions, 50-50. So let's put this into our calculator. At least 3 20 questions. Let's see if I can remember all this on my calculator. All right, so I'm at my calculator. We're going to go menu 5, 5, but we're not going to A this time. We're going to B, CDF. There are 20 questions on the test. You have a 50% chance, 0.50, a 50% chance of getting it correct. Remember, at least 3. 3 was the lowest number you could get correct, and 20 was the greatest. At least 3 means between 3 and 20. And when I hit OK, there's my probability. And question 20 is 0.9998 if you take it to 4 decimal places. So for this problem, we did menu 5, 5B, n equal 20, probability equals 0.50. The lower number equals 3 and the upper number equal 20. And I got an answer of 0.99979, but 4 decimal places is that right there. Question 21. If 60% of all women are employed outside the home, find the probability that a sample of 20 women, at most 5 are employed outside the home. So 20 women, 1, 2, 3, 4, 5, 6, 7, 20. I'm gonna put a blank and put a 20. 1, 2, 3, 4, 5, 6. So it says find the probability if 60% are employed. So probability that employed outside the house is 60%, 0.60. At most 5. So 5 is the most. At most 5. 5 is the most. So all these numbers could happen. Oh, you could even happen 0. 0 can be employed outside the home. So at most is 5. At most 5 is the most. So these are the numbers between 0. 0 is the lowest, and 5 is the highest. So once again, n equals 20 in this case, sample of 20 women. At most 5. So low is 0 and the high is 5. Low is 0, high is 5, and probability is 60. So on my calculator, I'm going to do menu 55B, just like last time. Number of trials, we said 20 trials. Probability of success is 0.60. The lower band, you could have 0. The upper band at most was 5 correct. And hit OK. I think in the last one, no, we did everything correct. There's our answer. For 21, 3 decimal places would be 0.002. 3 decimal places would be 0.002. If they did 3 decimal places here. I mean, just depending on what they want. So once again, n equals 20, my probability equals 0.60. The low number is 0, the high number was 5. We did menu 55B, and we got this answer. 0.0016, 3 decimal places is this. All right. Okay, question 22. There's 2 parts to 22, I guess. Use the standard normal distribution table, find the area. Here's a normal curve between, here's a z-score of 0 between 1.5 and 2.5. So we want to find the area shaded between 1.5. What percent is shaded in between 1.5 and 2.5? So 1.5 is our low end, and 2.5 is our high end. So all we need to do is go to our calculator. And go to 552. So on our calculator, we're going to go to menu 552. All right, 1.5 and 2.5. So on our calculator, just in a calculator page, going to menu, 5 probability, 5 distribution, and 2 normal CDF. Our lower bound here we said was 1.5. Our upper bound was 2.5. And we keep the mean at 0 and standard deviation at 1 when we use the Z tables, and 0.06059 is the answer. .06059 is the answer. Once again, we did a normal curve. 0, Z of 0 is here. We did from 1.5 to 2.5. This shaded in region. This is the lower. This is the upper. And when we put that in our calculator, menu 552, lower was 1.5, upper was 2.5, and we left the mean and standard deviant at 0 and 1, and we get an answer of 0.06059. If we go 4 decimal places, 0.0606 is the answer. And that's 22A. All right, if we go to 22B, if they want, here's 0 for Z, standard curve that lies to the right of 2. So here's Z value of 2. To the right of 2 is this way. So we're going to use 2 for the lower and 99 for the upper. We use, for infinity, we use 99 as Z value of upper. So we're using 2 and 99. 99 is our infinity. Menu, so on my calculator, I'm just going to, once again, to menu 552. Menu 552. The lower is 2. The upper is 99. If I leave everything else the way it is, I get 0.02275. So this shaded area is 0.2275. 4 decimal places is 0.2. Oh, there's a 0 I'm missing. 0.0228. 0.0228 is our answer for this problem. All right, let's try question 23. It's always good to draw these normal curves so you understand what's going on, I think, when you're doing this. Same as this one. I mean, if you look at it, use the standard normal distribution. It says TI-84, but we're using the TI-Nspire that lies to the left of 0.37. So once again, let's just draw the normal curve. Here is 0. So to the left of 0.37, 0.37 has to be somewhere over here because it's positive and it's to the right. So it has to be to the right of 0. So we need to find area under the normal curve that lies to the left of 3.7. All of this is to the left of 0.37. So we're going to use negative 99 as negative infinity That's our lower bound. The left side is always the lower bound. Our upper bound will be 0.37. So let's put negative 99 lower and 0.37 as our upper. Menu 552 and negative 99 as our lower. And our upper, we already said we're going to use 0. I don't know what we've said. Let's take a look at it again. .37. 0.37. Oop, that's in the wrong spot. Sorry. There we go. If it lets me do anything, it's just taking its time. It's not letting me. .37, 37, and there. Now we got it to match up. And there's my answer, 0.6443. Negative 99 is the lower, 0.37 is the upper, and we always keep it at 0 and 1. So if we look at our answer here for 23, .37 and negative 99, we get 0.6443 as my answer. 60%, 64% is shaded in. All right, question 24. Survey indicated on the trip. The average of 45 minutes. Standard deviation of 12 minutes. Normally distributed, a shopper enters the store, finds the probability the shopper will be in the store more than 39 minutes. More than 39 minutes. So if we do this normal curve, if I can draw a normal curve, but just a little bit better than that. Here's a normal curve. If you remember, our average is 45. That's our average, or z-score of 0. It says more than 39. Well, 39 would be over here. 39 minutes would be over here. So we want a z. We want to find that z-score right here of right here. We want to find that z-score. We know the maximum z-score here is positive 99, infinity. So the upper is going to be positive 99. We just have to find this lower z-score. And so one way of doing it is finding the X value for that spot and then finding the z-score there. Remember, there's a formula, z equals X minus X bar over standard deviation. Well, we want to find the z-score. And we know we need to find it for 39. X is 30. We want to find the z-score for 39. Our average was 45, and our standard deviation was 12. 39 minus 45 is a negative 6. Negative 6 over 12 is a negative 0.5. So that's our z-score, a z-score of negative 0.5. That's our lower z-score. and this is our upper 99. So we just need to find the area between negative 0.5 and 99 on my calculator. Menu 552. The lower is negative 0.5 z. The upper z-square was 99. And from here, I can tell you how much was shaded in, and 0.6914. So for this particular problem, we ended up with 0.6914. I think there's more. 1462. 4 decimal places. It's right there. And that was the normal curve. Once again, we went all the way to 99, more than 39 minutes. 39 minutes was somewhere around here. And we found this z-score be negative 0.5 when we did it. We use this as the lower, and we use this as the upper when we did menu 552. Okay. Question 25. The mean room and board for college is average. Mean is same thing as average. Is this 7540? You randomly select 9 four-year colleges, n equals 9. What is the probability that the mean room and board is less than 780? X is less than 7,800. So if you looked at this, our average is 7540. We want 7,800 is somewhere over here. Less than 7,800 is all of this. So we have to find this z-score here. We know this z-score, negative 99. So we have to find that z-score at 7,800. And it tells us our standard deviation is 1245. So this problem is a little different because of the formula. So we have to find that z-score, x minus x bar over standard deviation over the square root of n. Because this is a sample and we have an n of 9, it says right here, 9 four-year colleges, we did a survey. This is how we find the z-score. So once again, z equals the x is 7,800. The average was 7,540 over standard deviation was 1245 over the square root of 9. So that z, when I put this z into my calculator, let's see what I get. 7,800 minus 7,540. Divided by parentheses 1245 divided by the square root of 9. And when you put this in your calculator, you definitely don't get that. You get 0.626506. So this is what I get. It's a little off from what's in the book, what's on the answer key. But this is what I get, about 0.62. Oh, wait, that's the Z value. 0.62. So let's put this as the low and this as the high and see what we get. Menu 552, the low is -99 and the high is 0.62. And I get then the average of 0.73. % shaded in. I get 0.7323. So about 73% shaded in. All right, let's take a look at question 26. Question 26. A simple random sample of 18 adults. This is N. N equals 18. Estimate the mean calcium intake of all adults, including below the poverty level, with 95% confidence interval. So we're looking for a confidence interval of 95%. Standard deviation, population standard deviation, it says is 188. And here's all our data we need to place in first. So we're going to load up all our data into L1. We're going to find the mean, putting all this data into L1, and then we're going to find the confidence interval. Okay, so I added all the data into my calculator. Remember, we're doing 95% confidence interval. Standard deviation is 188. I'm going to start. Let me just, it'd probably be easier for me to start over. If I go new, there's question 26. Let's see if I can get to it again. There we go. Okay. Okay, I had it. Now I don't have it. Give me a second. Okay, so I entered all my data into list 1. Hopefully I got it all correct. Moving over to the right, go to menu, 5, 3, 5, 4. Give me a second. Never. Things just the menu 5. It's not menu 5. It's menu 4. Menu 4, 3, 1. 3 and 1. And the data is going to be there from the list. Our standard deviation, they said, was 188. Our list is in L1. And 95% confidence interval. And this is what I get. I get a low of 830 and a high of 1034. I know that's not the correct answer. Well, that is the correct answer. I'm going to say this is the correct answer, but in the assignment sheet, I don't think number 26 is written correctly. So it should be 860.5, and then the high should be 1034.2. The confidence interval is 860 to 1034. So yes, I do know it's not the same answer as in the answer key, but this is more accurate. Hopefully it is correct. It looks like all my numbers are right. So we went to menu 4, 3, 1. So when I hit menu, we go to statistics, then number 4, then number 3, confidence intervals. And then number 1, Z intervals. And data, just say data because we have our data on our list. Just say okay. Standard deviation, they gave it to us as 188 down here. List should be L1. Or whatever you labeled it. C level is 95. And then just hit OK. And I get 860.5 as a low, and the upper is 1034.2. So this is what I get. I know it's different from what's in the answer key, but I would use this. This looks more accurate because they said the average, is the recommended daily dose is 1,000. And you should have 1,000 in here somewhere. You know, the 1,000 should be above and below. So it's closer to 1,000 here. So I think this would be more accurate as long as I typed in all the numbers correct. Okay. Next question, 27. Compute your y equals. Compute your least square regression. This is L1. This is L2. So let's type all that in right now. So on our calculator, once we type all this into L1 and L2, we're going to go to menu for 4A. Let's try that out. Let me just look. Menu 4 is statistics. Four is stat tests. And then scroll all the way down to A, linear regression. And then fill in the blanks. X list is L1, Y list is L2, and keep everything else as it is and then hit OK. And when you do that on your calculator, you can look at, let me show you here. We can look at 44A. Once I type it into my calculator, once I have it all in there, you can see there's my data. And I actually did it twice. I thought, oh, there it is. You can see there's the regression formula, A plus BX. And there's the A, 94.86. And there's the B, negative 0.8456. So we need the A and the B when we do linear regression here. We need that A and that B. So let's go back up. So our formula that we're looking for is Y equals trying to get there, hang on. Y equals A plus BX. This is that one line. And then when I scroll down to A, I get 94.86, and B, I get negative 0.8456. So you just fill this in, Y equals A, 94.86 plus B, and I say plus because normally we put a plus, but this is a B is negative, so we put minus 0.8456 X, and this is what the formula looks like. So you see there's A, and there's B, and there's the X. So there's the linear regression formula for 27. All right, question 28. A school publicizes proportion students who are involved in at least one extracurricular activity is 61%. So the key is you have to remember this. We have an HO and an H1. There's only 3 possibilities that you can write down. There are only 3 possibilities. Let me show you all 3 before we begin. You can do an average or a P. It doesn't matter, an average or a P. The first problem is a P. P equals. The first answer has to have P equals or the average equals. The second answer, you can have a not equals, you can have a less than, or you can have a greater than. These are the only 3 possible answers you're allowed to have on a test. So when it says a student who is involved in at least one extracurricular activity, at least one, so at least one is the least, that means more than one. the P is greater than 1. So you're looking for at least 1 or greater than. So this is the answer for the first one. HOP equals 61%. There's it, equals 61%. H1 is P is greater than 61%. That's the answer to number 28. You have these three to choose from. And we chose this one because it was the greater than. At least means greater than. So let's try the next one, 29. Once again, for 29, you have three choices. HOH1, HOH1, HOH1. The P's, or in this case, the averages, have to equal. The first one, they all have to equal. Then you can say not equal. Then you can say less than, or you can say greater than. A car dealership announces the mean is less than 15 minutes. The mean is less than 15 minutes. Less than is this one. So this is the answer. HO, the mean equals 15 minutes. H1, the mean is less than 15 minutes. That's it. That's the answer. And we have one more. Question 30. Question 30. HO, H1. So we can have equals or not equals. We can have equals or less than, and then we can have equals and greater than. A company advises the mean life insurance is more than 18 years. More than, greater than 18. So this is the answer. When it says greater than 18, you got to go for the greater than symbol. All right. I hope this review helped. There's a lot involved here. Make sure you have these steps and procedures for the calculator written down. I mean, that's the key. Making sure you have everything on the calculator, the steps and procedures for the calculator written down. It's really, really important. Hope you guys enjoyed the video. I know it was long. Good luck on your final exam. Bye all.